Welcome to the deep dive. Have you ever looked at a rainbow and just felt there's something more going on than just pretty colors?
Definitely.
Well, today we're diving right into that. We're going to try and unravel how a simple rainbow might actually hold some pretty deep secrets about the universe itself.
Yeah, it's surprisingly profound.
We're exploring this observation that seems simple, but, well, it gets complex fast. Rainbows
Hmm.
appear one way. It's not just a visual thing,
Yeah.
It feels like a clue, something that could open doors to understanding the universe, its structure, maybe even ourselves. And it really starts with, why is the rainbow directional? Why not symmetrical? So let's unpack this a bit. The source material really highlighted this feeling that it's kind of odd that the light refraction, it only seems to work one way.
Right.
It doesn't wrap around the sun. You never see it in front of you towards the sun. It's always like in a specific spot.
And that's a brilliant place to start, really, because it gets right to the heart of the physics. Rainbows pop up when light enters raindrops from a very, very specific angle relative to your eye.
Okay.
And crucially, the sun has to be directly behind you. It's like finding this perfect little sweet spot where the light does just the right thing.
So only light bouncing back in a certain way.
Exactly. Only the light that gets redirected along this really narrow path backwards towards your eye actually shows up with that vivid color separation. So yeah, for you to see a rainbow, sun's got to be at your back, rain in front. Simple as that, but profound.
Okay, but why isn't it symmetrical then? Why doesn't light somehow come back from the other direction too? It feels like it should balance out.
Yeah, that's the fascinating part. Light does actually refract and reflect in, well, pretty much all directions inside those tiny water droplets. It's bouncing all over.
So why only see it one way?
It's the constructive geometry. That's the key term. Think of it like the specific interwoven paths the light has to take inside the droplet to create that visible separated spectrum. It only works constructively from one side. You absolutely need that internal reflection inside the droplet. Light just can't physically enter from your side, bounce off the back of the droplet, and then come back towards you to form that specific arc. It sounds complicated, but the geometry forbids it.
So it can only form in that one sort of half sphere, always opposite the sun?
Precisely. Opposite the anti-solar point, technically.
Okay, so beyond just the direction, another thing that came up was the color order. Why is it always red on the outside and violet on the inside? Like, could it ever flip?
Right. Another great question. And that fixed order tells you how deep the physics goes. It's not random. The colors get sorted by their exit angle coming out of the droplet.
Exit angle.
Yeah. Red light, it bends less when it goes through water. So it exits at a slightly wider angle, maybe around 42 degrees relative to that incoming sunlight path, back towards you.
And
Violet light bends more, higher frequency, interacts more. So it exits at a slightly tighter, narrower angle, maybe 40 degrees.
so the angles are different for each color.
Exactly. So as you look up, you see red light coming from droplets a bit higher up on the outermost edge of this sort of cone of light reaching your eye. And you see violet from droplets just a little bit lower on the inner edge.
Yeah.
That locks in the order. Red outside, violet inside.
And the key thing is each tiny droplet is only sending one specific color to your eye at that perfect angle, right?
Precisely. You're seeing red from those drops up there, violet from these drops down here, all contributing to the whole arc.
And just to be sure, a primary rainbow, the main bright one, has to have that order. Red, orange, yellow, green, blue, indigo, violet, outside to inside. It can't flip.
Absolutely. It's fundamental. I mean, having violet on the outside of a primary rainbow, red on the inside, that would literally violate Snell's law.
Which is like the basic rule of refraction.
Exactly. The rule for how light bends going from air to water. Now, you do sometimes see a secondary rainbow.
Ah, yes, the fainter one.
Right, the fainter one higher up. And that one does have the colors reversed violet outside, red inside. But that's because the light reflects twice inside the droplet, not just once.
So it's a different process, different geometry.
Totally different phenomenon. And it actually reinforces the rules for the primary one. One bounce, red outside. Two bounces, violet outside. The physics is consistent.
Okay, so we've kind of nailed down the physics of why it's one way, why the colors are ordered. But this asymmetry, this one-sidedness, it feels like it's pointing to something bigger about the universe, doesn't it?
It really does. That's a great transition. Because the rainbow's directionality, it isn't some kind of universal imbalance. It's actually profoundly observer-centered,
Meaning?
meaning every single person, every observer sees their own unique personal rainbow. It's formed by light interacting with different water droplets specific to your line of sight.
Ah, so the rainbow I see isn't the exact same arc of light particles that you see, even if we're standing side by side.
Exactly. Your rainbow is made from your set of drops, mine from mine. So the asymmetry isn't a flaw in the universe's symmetry. It's a product of your specific perspective. It's balanced perfectly, but within your personal frame of reference.
And thinking about it, the sun itself is kind of a one-way street for light, right? It's blasting light outwards. Does the rainbow relate to that? Like some kind of cosmic ripple effect?
That ripple idea is quite good, actually.
Yeah.
You can almost think of the rainbow as a sort of, well, maybe like a bow shock, where the sun's unidirectional light hits the resistance of the water droplets and then gets reflected back in this very specific directional pattern. But the truly deep insight here, which the source material hinted at, is that the universe isn't perfectly symmetric. Not at the deepest levels. In fact, it's broken symmetry that allows for form, for difference, for direction to even exist.
Broken symmetry. Like how?
Well, think about basic things. Why isn't your left hand identical to your right? They're mirror images, but not superimposable. That's chirality, a form of broken symmetry. Or, why does time seem to flow only forwards? The arrow of time. That's another profound asymmetry. The weak nuclear force in particle physics also violates certain symmetries. It turns out asymmetry isn't a mistake, it's the engine of creation. It's what allows structure, difference, well, everything interesting to emerge.
Wow. Okay. So this connects to other stuff we wonder about, like why galaxies and planets tend to spin in one direction. Is that related to this asymmetry idea?
That's a fantastic example. On a local scale, say, for our solar system, the spin comes from the conservation of angular momentum. Imagine a giant gas cloud collapsing to form the sun and planets. Any tiny, random initial rotation gets hugely amplified as it shrinks down, like an ice skater pulling your arms in, right?
They spin faster.
Exactly. But the really deep question is, why was there any initial spin at all? In a perfectly uniform early universe, you might expect everything to cancel out.
So where did that first tiny bit of spin come from?
Cosmologists have ideas. Maybe tiny quantum fluctuations in the very, very early universe got magnified. Or maybe there's a deeper cosmological arrow of time, like a preferred handedness built into space-time itself. Interestingly, some recent huge galaxy surveys, they hint at a possible, very slight statistical preference for spin direction across vast cosmic scales. It's still debated, but
The point is asymmetry isn't a bug, it's a feature.
absolutely, it's essential. Think about the slight imbalance between matter and antimatter right after the Big Bang. If it had been perfectly symmetrical, they would have annihilated each other completely, leaving just energy, no galaxies, no stars, no us. Asymmetry allows existence. It allows structure. It allows a story to unfold.
Okay, mind kind of blown there. So we're seeing that the rainbow's asymmetry isn't just about angles, it's pointing to these fundamental cosmic principles. But could this experience, seeing this rainbow, imply something even bigger, like time, energy, perception itself, all somehow emerging from geometric constraints?
That's a really powerful leap, and I think the source material was definitely heading there. It sounds instantaneous when you see a rainbow, right?
Yeah, totally.
But physically, the light paths for each color, red versus violet, involve slightly different optical path lengths inside the droplets. They travel slightly different distances.
Ah, so they don't arrive at exactly the same micro instant.
Precisely. It's an incredibly tiny difference, femtoseconds maybe, way too small for us to perceive. But technically, yes, red light takes a subtly different amount of time to reach your eye than violet light does. So there is a temporal structure embedded in what you're seeing.
Wow. So this idea that wavelength equals energy, which defines the path, which carries information, that sounds incredibly fundamental. How does a simple spatial constraint, like the angle of light hitting a raindrop, generate all of that complexity?
It's quite elegant, really. The wavelength of light intrinsically defines its energy, right? Higher frequency violet has more energy than lower frequency red. When that light encounters a specific geometric setup, the raindrop, that geometry forces the light onto particular paths. And because different wavelengths interact differently with that geometry, they get shunted onto slightly different paths and, crucially, experience those tiny time delays.
So the space dictates the path, which sorts the energy, which creates a time difference.
You got it. The spatial constraint, the angle relative to the drop, leads directly to energetic differentiation, the color you perceive, which is linked to a temporal difference, the arrival path, and timing. The raindrop acts like a tiny geometric processor. It doesn't invent the information, it reveals what was already bundled in the white light through interaction.
And this isn't just rainbows, is it? This idea that geometry shapes energy and time.
Oh, it's everywhere in physics. Think general relativity curved space-time geometry literally dictates how matter moves and how time flows. Think quantum mechanics, the shape of the box a particle is in determines its allowed energy levels. Boundary conditions define outcomes. It might even apply to consciousness itself.
Which brings us to maybe the most radical conclusion from the sources. Things are only asymmetrical when they are observed or interacted with. Otherwise, everything tends towards symmetry. That feels huge.
It is huge. And it connects beautifully, almost perfectly, with quantum mechanics. Before you measure a quantum particle like an electron, it exists in a state of superposition.
Meaning it's kind of everywhere at once or in multiple states?
Exactly. It's potentially spinning both up and down or located in multiple places simultaneously. Think of it like a spinning coin before it lands. It's neither heads nor tails, but potentially both. That's a state of maximum symmetry, maximum potential.
Okay.
But the moment you observe it, the moment it interacts with something, its wave function collapses. It chooses a state. The coin lands heads or tails. The electron is measured spinning up. That's asymmetry. The potential collapses into a specific actuality through interaction.
So symmetry is the default state of potential. And asymmetry is what happens when things connect, when they relate.
That's a fantastic way to put it. Symmetry is the natural state of undifferentiated potential. Asymmetry arises from connection, from interaction, from relationship.
And if we look at something bigger, like planets orbiting, they're not just passively following paths, are they? Their orbits wobble and spiral because they're constantly interacting. That's an asymmetry of interaction over time.
Precisely. It's a dynamic dance, not a fixed track. And this leads to a really bold implication for something like consciousness. Maybe consciousness isn't a static thing inside our heads.
But more like an event.
An event, yes. An event of asymmetry that arises purely from relationship. The fundamental ability to distinguish me from not me, subject from object that is itself an asymmetric stance. It's a dynamic boundary drawn through relational geometry.
And the power comes from choosing that asymmetry, choosing to engage.
Exactly. Choosing to perceive, to relate, to interact. That act of choosing an asymmetry might be fundamental to awareness itself. The supercondition, as the source put it, is the power that comes from choosing an asymmetry.
Okay, let's dive even deeper into the why then. Why does red light bend less and violet light bend more in the water drop? What's happening at that really basic level?
Yeah, good question. It's a phenomenon called dispersion. Fundamentally, light bends or refracts because its speed changes when it goes from one material like air into another, like water.
Okay, speed changes, but why differently for different colors?
Because each wavelength or color interacts differently with the electrons in the water molecules. Violet light has a higher frequency, shorter wavelength. It interacts more strongly with those electrons. That interaction sort of slows it down more.
And more slowing means more bending.
Exactly. More interaction, more slowing, more bending. Red light, with its lower frequency and longer wavelength, interacts less strongly, so it slows down less and therefore bends less. It's an intrinsic property of how electromagnetic waves interact with matter. It happens incredibly fast on femtosecond timescales.
This might sound naive. How does the light know what color it is before it hits the droplet? Does the droplet somehow paint the colors on?
Haha, no, that's a great clarifying question. It doesn't work like that. White light, like sunlight, isn't actually blank or colorless. It's already a mixture, a combination, a superposition of all the different visible wavelengths. Red, orange, yellow, green, blue, violet, all traveling together.
Ah, so the colors are already in the white light.
Precisely. They're bundled together. The raindrop doesn't create the colors. It acts like a prism. It sorts the waves that are already there. Based on how each specific frequency interacts with the water structure, it gets bent by a different amount.
So the droplet just reveals the frequencies that were present all along through that interaction.
You've got it. It reveals the pre-existing frequency content.
Okay. Now, this links to another really critical point from the source material about the very early universe. The idea that it didn't start as some dense, chaotic mess.
Right, not like a compressed version of today.
But more like a near-featureless field, mostly just flooded with light and hydrogen, with really low gravity, low density, not much structure.
Yes, that's key. That initial state is seen as the core condition needed for emergence to happen at all. Think about it. Hydrogen is the simplest atom, the first stable boundary. Light is the simplest form of energy exchange, communication.
The basics.
The absolute basics. They represent the simplest expressions of what you might call constrained symmetry. And crucially, that low gravity and low density allowed the universe to expand. That expansion created this space, literally, for boundaries to emerge, for symmetry to break probabilistically, for complexity to arise over time.
They were like the universe's first self-defining acts.
Beautifully put. They are the fundamental building blocks, the canvas, and the first paint strokes from which everything else could differentiate and emerge. Without that simple starting point, maybe nothing complex could have ever formed.
And this leads to that incredibly direct, almost startling realization from the source. Where in our universe are light, electromagnetism, and hydrogen not anywhere important? And the answer is, that's you.
Exactly. It hits home, doesn't it? It's not abstract. You, me, the listener, we are mostly hydrogen atoms. The atom of the cosmos, the first boundary.
Structured by?
Structured by electromagnetic fields. That's what holds us together, what allows our nerves to fire, our muscles to move. And we perceive the world primarily through photons light interacting within a relational geometry. They aren't just ingredients in us, they are the very mechanism of our emergence, our coherence, our perception of time, our awareness itself.
Wow, okay. This entire deep dive has been, well, pretty mind-bending. But the ultimate breakthrough insight, maybe captured best by the source's own words, is simply everything acts the way it does because that's the way it is and always has been.
Right. It sounds almost like a tautology, like saying it is what it is, but it's deeper than that. It's what the source called the principle of always. Meaning, instead of searching for endless layers of hidden causes for why light bends just so, or why hydrogen forms stable atoms, we recognize these fundamental behaviors as simply the way reality expresses itself. They aren't caused by something else. They are the base layer of expression.
So structure emerges, asymmetry is how things express difference, and relationship is how anything becomes tangible, real, perceivable.
Precisely. It's about the inherent nature of reality manifesting itself.
And then bringing it right down to the most practical human level was that other profound insight. Every problem and answer is because it either lacks or gains awareness from relation.
That one is incredibly powerful because it reframes so much. It posits that awareness is relationship, not just related to it, but is it fundamentally. And this applies across the board.
Like in health.
Absolutely.
Yeah.
Think about health and illness. Instead of seeing, say, inflammation or even cancer as just a localized mechanical failure, a broken part,
Reframe it
as a disruption of awareness, a breakdown in the relational coherence within the body's systems. The source even suggested aging could be seen as the body forgetting itself, a gradual loss of that coherent systemic relational awareness.
and toxins.
Toxins could be things that interfere with that awareness, things that fragment the body's internal communication. So real healing isn't just about attacking a symptom, it's about restoring clear relational awareness across the whole system, helping the body remember its coherent wholeness. And you can see the same pattern in psychological disorders, too. Things like trauma, anxiety, depression, addiction. You can trace them to distortions or blockages or fragmentations in the flow of awareness.
Like seeking connection or failing to find it. Disconnected loops.
Exactly. Seeking or failing to find those healthy relational loops, either internally or externally. So healing, again, becomes about restoring safe, clear relational awareness, reconnecting those fragmented parts.
So the big implication here, especially for something like medicine, it suggests there's never going to be that single magic pill, is there? That one compound to fix everything.
Probably not, because if this perspective holds, the body isn't just a machine you can swap parts in and out of. It's a living, dynamic web of self-aware relationships, a complex system constantly adapting.
Which means healing has to be...
It has to be integrative, adaptive, and fundamentally relational. It's about restoring the flow of awareness and connection within the whole system.
So we have to leave it there, but here's the thought to take away. How does really internalizing this idea that awareness is relationship change how you perceive your own body, your interactions with others, the world around you? What new possibilities might that open up for you just in your daily life?